Now that we've looked at some common reports that might be helpful if you plan to implement pFSense on a production basis, let's take a look at packages, because there are some important packages that will definitely enhance the overall experience. We'll just perhaps implement one, and that's it. You'll get the sense as to how you may integrate it into your environment. So, packages. So we've mentioned that pFSense is extensible. So packages provide that extensibility. It introduces or permits the inclusion of capabilities that are external to pFSense, subsequently making it extensible. So for example, one of our favorite programs, nmap, most everyone in security's favorite programs, nmap, is one of those components not included by default with a pFSense standard build, but can be incorporated and is considered stable and can be used to scan the various nodes that are attached to interfaces accessible to pFSense. So let's look at setting that up rather quickly. So a simple task for us is to install the nmap package. Now we should note that packages tend to be classed, so let's just say tend to be classed as one of alpha, beta, stable. Certainly the categories are likely to change or subject to change as anything in life. However, when you look at the available list of packages, you'll see these labels, and of course, for obvious reasons, for production systems, it's advised that you consider implementing the ones that are stable. So, where do we find packages? Well, to do so, we'll navigate to System, Packages. This will give us a sense of the packages that are installed and are available. So let's take a look at this quickly. So System Packages. None are currently installed, however, many are available. And you'll see the various categories as we've mentioned, alpha, beta, and stable. So one tactic to determine whether or not a non-stable, and even for stable, package is suitable for your production environment is to maintain a mirror image of your firewall through virtualization. So you may have your actual pFSense physical deployments installed without extra bells and whistles and just maintain some virtual instances to be able to test these capabilities. So you'll find packages available for any functionality supported by Unix, Linux, open source related operating systems. Asterisks, for example, for VoIP services, Apache mod security, and the list goes on as you go through backup, Bacula, ARPing, etc., which of course is already available and is integrated in the overall set. Now in terms of nmap, there's a Bacula client, by the way, if you're using Bacula for backup purposes. In terms of nmap, let's search this page, Control F, and we'll see towards the bottom that it's considered stable. It's close to the latest version available. It's good enough for us. It'll be integrated into the interface, into the web configure interface, which makes it easy to use. I guess that's another feature that we should mention, that packages are integrated, which we take for granted, into the web configurator interface. So just as you have access to the command line from web configurator, you have access to other tools such as nmaps. It means you really need not know how to administer BSD in order to use pFSense, which is what the promise is. So if we want this package, it's as simple as clicking on add. You'll see a description here as to what the package can do. We already know what nmap can do. If you're not clear, have a look at Linux CBT Reconnaissance Edition or any distribution that we cover where we include nmap. So this will download and install, returning what's normally presented on standard out the shell nmap, and will give us this version 6.4.0, and we should have that momentarily. So at the end, writing configuration done, installation complete. Make sure the package is configured from the respective menu, and then start the package. So where exactly is the package installed? Well, if you look at lists of install packages, you'll see now that nmap is installed, but where exactly does it put it? Is there a short link or a click or so on and so forth? Notice that this gives you the opportunity to reinstall components, the nmap package as well as the nmap GUI components, or to remove the package altogether. Navigate over to diagnostics or status. Usually diagnostics will have programs like nmap. This is where you'll find the package. So diagnostic, nmap, and then you'll see the form fields that cover the key ones that are specified in the command line to nmap. So system packages, add nmap, and then search diagnostics at the end of the installation for nmap, and then execute. So install, execute, and return or evaluate, etc. So to execute, we need some targets. Well, you need to determine where the targets should be found. If you use any, then of course the kernel will match, BSD kernel will match the IP you specify to a target. So if it's not on the local network, it'll send it to the next default gateway. For this system, there are two local networks, WAN and LAN, 192.168.75.0, 192.168.1.0. So you can indicate any and it'll find it, or be more specific and indicate the interface. This is no different than telling nmap which interface to use from the command line. So if we like to scan, say, the nodes on our subnet just to see who's out there, you can do a 1024, and you can perform any type of scan you'd like. Since this facility runs as root, it has access to perform SYN as well as any other lower level scans. And you can do ARP scans for directly connected networks, of which these two are certainly. And of course, you can scan remote systems such as any on the internet, but of course you can't perform ARP scans on those that are outside of directly connected nets because we don't have L2 access. You got some timing settings, some options such as get TCP/IP fingerprinting or fingerprint the systems via TCP/IP, so on and so forth. Get service versions like we like to do, and adjust the scan accordingly. So let's go ahead and just kick off a scan on the subnet, see what comes back. As we'd expect, we should see some sort of output similar to what nmap dumps on the command line when we execute similar scans. So again, this is no different than executing an nmap as follows, with a service scan and operating system fingerprinting via TCP/IP, which you can normally combine with the A option against a particular target range of 1.0/24. It's the same thing, but you don't need to know the command line set. You just need to know some basics such as what you'd like to scan and some basic options as they pertain to this particular item. So indicate basic options and scan. And let's just note, it is not necessary to know all the various nmap, and there are many options, simply destination and a few options. So at a minimum, you can specify a CIDR, and nmap will scan that CIDR. Now, obviously, we've told it to scan the entire subnet using a SYN scan. It's going to take a while, so we'll have to wait for the data to return. If you need to navigate to browse, etc., that begs the question, what happens if you navigate away as it's waiting to refresh here? Well, the advice is don't. So if you need to see another area, just use a command and navigate to that area. So if you need to see rules, for example, hold command if you're on a Mac, or perhaps Control or Alt on some other platform, and then navigate the firewall that way and wait for the return to come back. The PHP scripts that run within the web configurator within the context of nmap should be tweaked to have long timeouts, because it's expected if you're able to scan potentially thousands of nodes on various subnets that it'll take a while. So you should seldom get a timeout, but if you do, that's cause for concern. It is possible behind the scenes via the command line to make changes to the PHP configuration associated with the script. So let's just note that if PHP nmap script times out, you may need to update timers via CLI for web configurator. Or there may be a value that can be passed from the nmap app to extend the PHP script's lifetime. Now, this is taking quite a bit of time, and also begs the question, could you also launch another instance? So for example, diagnostics nmap in a separate window altogether. Let's say we scan a specific node or a range, say 192.168.1. maybe 102 through 104, and just perform a SYN against the LAN. And let's just make sure that this one's actually LAN, not WAN. That's LAN. That looks good. Still hasn't come back. And in this one, we'll try to kick off. Let's say we do the same service detection, OS fingerprinting, and scan here in a separate window. So each window that's launched launches a new instance of PHP running within LIG-HTTPD. So hypothetically, you should be able to execute multiple instances without much cause for concern. But if there are problems, if you find that your firewall becomes unresponsive or slow, then you may want to back out and consider doing something else, such as killing a process altogether. You can also get a sense as to how busy the server is. Notice it reads loading by looking at the default screen and getting a sense for whether or not the CPU utilization is rather high. So that's something. The dashboard should give you a sense as to whether or not it's quite busy as well. Let's take a look at dashboard here, status dashboard, see if this comes back. But launching a couple scans shouldn't overwhelm it too much, but sometimes it does. Remember, we're running pFsense within a virtualized environment, so that can cause the resources to be overwhelmed rather quickly. Like this is still, at this point, waiting to return information to us, so it's taking a bit. This is much slower than we expect, and these other two are still going. So this one's still deciding whether or not it's going to take us back to the dashboard. See if we can force it to. Now it's giving us a dashboard, and it's going to give us a CPU usage momentarily. We can also look at some of the graphs to see what the CPU usage is like, but since this takes 10 seconds, let's see what it comes back with. It's usually CPU that's driven up when you perform these scans, but it claims right now it's 0%. Let's see what's happening with this scan. It's actually come back. Here's the output. And this is a scan of 102 through 104. So 104 came back as a Windows node with the various ports open. Let's see what else has come back. That's it so far. So 102, the other nodes haven't come back. So 3 IP addresses, 1 host up. It has not detected the other nodes. It should have, because they are up. And there's other scans still going. And again, we hope the script doesn't time out, because that can be an issue. And again, if you follow the graphs that are available, you can get a sense as to whether or not the system's truly busy. So you take a look at the system, the processor, and see what it's doing at the current time over the 8 hour 1 minute, which is the most recent. But it shouldn't be too busy. Now this is taking too long. Now there isn't a cancel on this screen. You can try doing back and see if it lets you escape it. And hopefully that's killed the process behind the scenes. Let's see what this screen is doing here. So we haven't gotten the full scan back. So this is our scan here. And let's see what we've got. Let's try to do a 192.168.1.102, which is ubuserv on the LAN, and see what it comes back with, service and fingerprint. Again, it's not as comprehensive an interface as you'll find with the command line, but it does give you some capabilities to perform scans through the GUI. And you should also be able to scan internet resources as well. So let's try to do diagnostics nmap on maybe something online. And again, it's virtualized, so we expect some of these performance hiccups. So this has come back 102. It's found it up, so maybe it didn't or was unable to communicate with it before. Maybe it just timed out. Let's try to do a dev1 linuxcbt.com, see what it comes back with. And we'll just do a TCP connect scan. Usually those run faster than SYN scans. Let's see if this comes back with anything. It should know that it has to use the external interface just to kick that off. And here's the output. It's found these ports open as well. And the data aren't saved. It's just on the screen. So if you need to save this, you might want to save it. This has taken an inordinate amount of time, 28.313 seconds, for example, from the shell. We should be able to scan that node rather quickly. So that's a bit slow. So just because it's an available package in a firewall doesn't mean it'll necessarily run much faster. And of course, there are many other packages that are available. Just scan through the available packages list. If you no longer need a package, you can remove it. If the package is misbehaving, perhaps a component was broken during installation, you can reinstall it. And this also has GUI components, but everything's through the web interface, so it's restricted. It's all driven by XML. And again, you'll normally find those packages in diagnostics. Sometimes elsewhere, you'll just have to read the package information and get some details. Here's dev1. Here's a string that was actually executed by the PHP script. Again, because 1, we're virtualizing, 2, web configurator wraps via PHP the execution or call of nmap, things will be slower than running directly from the shell. So this is 32 seconds. So for example, let's say from one of our other nodes, let's say build 1, we just do a quick nmap against dev1 linuxcbt.com without any fancy assertions, and you'll see it'll come back more or less much quicker than scanning it through the wrapped interface of PHP, lig8, ggpd, etc. So 9.5 seconds versus roughly 30 seconds. So big difference. But nonetheless, this is a GUI way, a GUI means with which you can execute nmap. Again, just take a look at the packages that are available. Rather than go through all of them, just look at what's here. There's a lot of stuff, a lot of capabilities. Some are already inbuilt, such as TCP dump, the ability to sniff traffic, and all sorts of other things, proxies, TFTP, FTP, etc. But for example, the ability here to capture packets, packet capture, is a built-in or an inbuilt package. This allows us to scan for various types of traffic, for example, on the wire looking for basic BPFs or so on, and this will start the scans, give you the packet dumps as they come in. Maybe you're looking for certain ports, maybe you're looking for traffic headed to 3389 in the source of the destination field, given a specific source, given a particular protocol, TCP, IPv4 only, that narrows it down. And then this will scan on that interface, and then it'll diagnostically drop those packets here, such that if you generate some traffic, it should show up. So you try to connect to 3389, that initiates a connection, and that should show something coming up when you do stop. It's not dynamically displaying it, so do a stop, and you should see that the traffic came in. So here we came in on 92, try to connect to 3389, and here we see 104 responded to 92, and here we see a different packet from the original. So first, second, third, TCP handshake, etc. So you can do those sorts of things, and this is yet another package, but it's integrated into the overall pFSense. So you have a full facility here, and there are other packages available online that can be plugged in, but there's a full facility for implementing packages. Just stick to the ones that are stable, test the beta and alpha ones independent of your production item. Release is also a good level to look at. You also have release candidates, but let's just say alpha, beta, stable. Also release is pretty reliable, but nonetheless, stable to release should be your window of comfort. So with that said, let's move on to some other things that this firewall can do.